Hello and welcome to the ultrasonic rangefinder tutorial. In this tutorial, we will connect the sensor to the Arduino board, then we will program the Arduino board, and finally we will test the sensor to see if it works or not.
Okay, so we have the ultrasonic module, and we will see the ultrasonic module has 4 pins. These pins are labeled VCC, trig, echo, and ground. We will simply connect the VCC to the 5-volt pin on the Arduino. We will connect the trig to pin 9 on the analog, on the digital side of the Arduino board. We will connect the echo to pin 10 on the Arduino board on the analog side, and we will connect ground to ground on the Arduino board, and then we will upload the sketch.
We begin by connecting the sensor to the breadboard, and we will extend wires from the breadboard to the Arduino board. You can see the labels here. Okay, so I have connected the trig pin 9 on the Arduino board and the echo pin from the sensor to pin 10 on the Arduino board. We've also connected the ground pin from the sensor to the ground on the Arduino, and the VCC to 5-volt output on the Arduino board. And now I'm ready to upload the code to the Arduino.
Okay, so this is our sketch, and we begin by declaring a couple of variables to represent the trig and echo pins on the Arduino. The trig from the sensor is connected to pin 9 on the Arduino, so we assign it that value, and the echo pin from the sensor is connected to pin 10 on the Arduino, so we assign it the value 10. Then we declare a couple of variables, one called the time_traveled, and this will hold the time traveled from and back to the rangefinder, and then another variable called distance, and this will be the distance traveled, which is what we're looking for. Then in the setup section, we use the pin mode function to set the trig pin as an output, so the trig will send an echo, and we use the same function to set the echo pin as an input, as a digital input. Then we use serial.begin to initiate the serial communication, so we can use the serial monitor to read the distance. Then in the loop section, we start by turning off the trig pin, so we use digital write trig low. This will turn off the trig pin every time we loop, and then we wait for 2 microseconds, so we use the delay microsecond function, and we assign the value 2, so this will give us a delay of 2 microseconds. And then we use the digital write function again to turn on the trig, wait for 10 microseconds, and then turn it off. After that, we use the time traveled variable and the pulse in function to read the time traveled. This time will be the time it took the echo to go and come back. And then we use that when we're calculating the distance. So distance equals time traveled divided by 2 times 0.034. we are dividing the time traveled by 2 because the time stored in this variable is the time it took the echo to go and come back to the sensor. The time value stored in this variable is in microseconds. So since the speed of sound is 340 meters per second, we divide that by 1 million, and so we get 0.034 meters per microsecond. Finally, we use the serial.print to send the word distance to the serial monitor, and we use the serial.println to send the value of the distance to the serial monitor, but this time we add a new line every time we print the value of the distance. Then we loop again and we do the reading over and over again. We're now ready to upload the sketch, so let's do that. Okay, now that we have uploaded the sketch, let's bring up the serial monitor, and the serial monitor is just reading different numbers right now, but what I'm going to do is bring my cell phone, place it in front of the ultrasonic rangefinder. Now it's reading distance 7 centimeters approximately. If I bring it closer, it's reading 4. I bring it away from it, now it's reading 10, 9, 8, 7, 6. Okay, so I hope you've enjoyed this tutorial. Thank you for watching, and I'll see you in the next one.